Hi, in this video I'll show you how to set up an InstrumentDB instance and how to upload a description of the Planck instruments in the running InstrumentDB instance. For this purpose, I have created two repositories. The first one, Planck InstrumentDB demo, is a fork of the InstrumentDB page. So, have a look. InstrumentDB demo. Here it is. Okay, Planck InstrumentDB demo is a replica of the InstrumentDB database with a few changes to brand the product with a Planck logo and with a few additions in the code, which we'll see later. So basically, using Planck InstrumentDB is exactly like using InstrumentDB. We start it using Poetry. I already configured the storage, and oh, sorry, I need to enter the directory. I already configured the storage and the username and so on, so I can just open. Okay, and you see, I am logged into the database, but there is no data available. The entity tree is empty, format specifications empty. Now, the purpose is to fill it with some realistic data, not real, but realistic. And for this, I chosen to use the reduced instrument model in the Planck Legacy Archive. The Planck Legacy Archive is where Planck data is stored and kept permanently. It's a site managed by ESA. And together with maps, catalogs, and cosmological parameters, time sense, and so on, you see that there is also an instrument model section. Instrument model sections contains 3 files. Let's skip beams because we are not going to use them. The HFI REMO and LFI REMO are 2 FITS files containing a reduced description of the 2 instruments, HFI and LFI. Reduced because not every parameter that was used to characterize the hardware is stored here, just the most important. For instance, band passes. Here we see version 3 of the HFI REMO and version 3.31 of the LFI REMO, but we can access other products. You see that there is a collection of HFI REMO files, 4 of them. These files correspond to the first Planck data release, 2013, the second data release, 2015, the third and final legacy data release, Planck 2018, and the Beyond Planck release that was published in 2021, version 4. The same for LFI. So I chose to use these files because in this way I can show you how InstrumentDB manages the various versions of an instrument model description. So the idea is that we download all those FITS files, we extract some, not every information, but some information from them, and create small files, each containing a description of some part of the 2 instruments, and then we upload them into InstrumentDB. So I wrote a script, a set of scripts, in fact. Let me open another terminal. This one will be kept opened and running InstrumentDB as a server, but another one will be used just to interact with InstrumentDB, and I'll use it in a moment. And then a third terminal, 1, 2, 3, third terminal, which will be opened in the FieldDB with Planck data repository, which is a clone of a repository on GitHub. This is the address. Let me open it. Here it is. Okay. So this repository contains a set of Python files whose purpose is first to download the data from the Planck legacy archive, extracts a set of files from the FITS files, create a structure as an entity tree in the InstrumentDB instance that I am running, and then fill this tree of entities with actual data from all the 4 Planck data releases, all the 4 REMO files, 4 for LFI and 4 for HFI. Let's see how it works. First of all, I have a directory here called mock data, which is a directory created by create mock files from PLA. Let's remove it for the moment, because I'm going to generate it again in a moment. So, create mock files from PLA. It must be run use poetry so that the right virtual environment will be used. Its purpose is to connect to the Planck legacy archive, download the files, and create a mock data folder. Remember, I just removed it from my folder. I run it, and the script downloads the data from PLA and creates a set, a very large set of CSV files. So mock data has been recreated. It contains several subfolders. You see that under the LFI folder, I see 4 subdirectories. Those correspond to the 4 versions of the RIMO. So I see that there are several CSV files. This contains the bandpasses for each detector in LFI, and there are also 2 JSON files, full focal plane.json and reduced focal plane.json. Let's inspect them using JQ. So you see, the content of this file just contains a description of the 30 GHz channel, the 44 GHz channel, and the 70 GHz channel that were implemented in LFI. The average full width maximum, the noise level, the central frequency, and so on. A few parameters that you see are empty. JQ full focal plane, I get similar parameters, but for the full focal plane, so a full description of all the Planck LFI detectors is provided in these files. So I have several files, each containing different informations, and I want to upload them into InstrumentDB. The first thing to do is to be sure that there is nothing in the InstrumentDB instance that is a leftover from my previous attempts to upload the data. I can just check it by browsing the site and see that nothing is available, but to play safe, I can run under the directory of the forked version of InstrumentDB, where I find the command manage.py, delete all. This will delete all the format specification, entities, quantities, and data files from the database, but it will save the authentication information so that I will be still able to log into the database using my usual username. Now that the database is empty, let's fill it with some structure. So the program that has this purpose is create tree. Okay, so let's open again. Let's go back to the browser. There are no releases, but entity 3 will show that several entities has been created and several quantities as well, orbital parameters, for instance. There is no data file associated because I have yet to upload them, but the document specification is already here. And it says that the orbital parameters will be available in a file which is going to appear here, and this file will contain is going to be a spreadsheet containing 3 columns, because when I produced the data file containing the orbital parameters, I decided that this was the format. The purpose of a specification document is to explain the format, not the contents, because a document format specification is associated with a quantity, not with a data file. Okay, so back to the entity tree. Now that the tree of entities has been created, let's populate it with the description of the instrument as taken from the Planck 2013 data release. So the script that does this is create Planck 2013 release. Let's start it. So you see it's adding band passes and it has finalized the release. Let's have a look. If I refresh this page, nothing has changed because the tree of entities has not been modified by the script. The difference is that if I open payload telescope characteristics, a data file has appeared. Data file was uploaded on March 11th, 2013. This is the date when the HFI REMO file was created. When you upload files to InstrumentDB, if you don't specify the upload data, the actual data will be used. But in some cases, it's useful to provide your own data because you are uploading some old files, like it is our case. So if I click on telescope characteristics, I see that it's an Excel file. I can download it. If I click, I can open it. Telescope characteristics. So with some basic parameters taken from one of the pre-launch status papers, and reporting the size of the primary and secondary mirror. If I had some doubt in understanding the content of the Excel file, there is a specification document, which of course is a mock document because I actually wrote it, but the purpose is for the people that have produced the Excel file to include every information about how to interpret the contents of the Excel file in this document. Oh, sorry. I hadn't closed that. Okay, if I navigate the entity tree, I can see, for instance, that frequency 30 GHz has a bandpass. And if we click on it, there is a CSV file associated with a bandpass that was uploaded when the first data release was released. And here I can see a plot which was produced by this script. Create a Planck 2013 release called matplotlib to produce this plot. Okay, if I go to the home page, I see that a new database release has appeared, Planck 2013. There is a specific release document, which just tells us that this is actually a REMO file from the Planck 2013 data release. And if I click on it, there is a summary page. It is very, very short because very few information were included in the first version of the REMO files, but we'll see that this is not the case for the next versions. So let's do the same for the second data release, 2015, Planck 2015. You might notice that now the script is slower. This is because with the second data release, the REMO file includes the band passes for all the detectors, not only for the frequency bands. Let's have a look. If I refresh the page, I'll see that Planck 2015 has appeared. If I click on it, something has changed. The REMO file for the second data release contained a table which summarized the characteristics of all the detectors, and so my modified copy of InstrumentDB is able to take advantage of this information and to show it nicely formatted in a table. You see. If I go in the entity tree, payload, telescope characteristics is a quantity which has one file associated, still one file associated. There is no telescope characteristics for the 2015 data release. Why is that? Well, if I click on it, something weird happens because it shows me that this data file is part of two data releases. Well, the point is that the measurements of the radius of the telescope happened before the launch. And so for the second data release of Planck data, there was no updated information about the telescope, Planck telescope. So the point is that when create Planck 2015 release.py created the new data release, it simply told InstrumentDB, look, this data file, telescope characteristics, is the same as the previous Planck data release. So there is no need for me to upload a new copy to you. Just put a reference to the old one. This, of course, is not true for the band passes. So if I select the frequency band pass, I see that there are two files. The new band pass, which was estimated from better data available for the 2015 data release, but there is still the old version available. It wasn't overwritten by uploading the new version. If I click on it, I see a warning. If you are planning, the InstrumentDB web page is telling me, if you are planning to use this file in simulations or analysis, keep in mind that this is not the most updated information. There is a new data file related to this very quantity. And if I click on it, I'll move from this page related to the 2013 version to November 20th, 2014, which is the data when the second version of LFI REMO file was created. Okay, and the same happens for other quantities. For HFI, for instance, you see the same applies. There is an old version of this band, but I can move to a new version of the band. So at this point, we can quickly produce the newer data releases. Fast forward in time, 3 years forward. And then beyond the Planck data release. And that's it. Now, if I go to the home page, 4 data releases are available, and they are listed in their order of appearance, starting from the most recent one. The table is still available, you see, and the entity tree contains several versions of each data file. You see 4 versions showing the evolution of the estimate of a band pass in this case. You see. Okay, this completes the video. Thanks for having watched.